So I'm going to be looking at math, review, and problem solving section 4 in the worksheet packet PDF. This will be page 143. I'm going to do a problem from the conversion part, number 1, and a problem from expressing the results of the computation to the correct number of significant figures. So let's look at 1A. Very good problem. So they want the following conversion to be made. 5.66 meters cubed to decimeters cubed. Remember, this is a derived unit. Meters cubed is a volume unit, meters times meters times meters, or length times width times height. And we are dealing with a base unit, meters, and decimeters. We must know that decimeters, what the prefix means, and remember, we should know that 1 meter is equal to 10 decimeters. And we just need to memorize that straight from our conversion and prefix slide. Now that we know this information, we can set up our dimensional analysis properly to be able to achieve the correct answer. And the dimensional analysis will start with the value that we have, 5.66 meters cubed. We make our dimensional analysis box. We know that meters cubed is going to be on the bottom, and decimeters cubed is going to be on the top, because we are canceling out the unit that we are moving away from and leaving us with a unit of interest. Very important to note here, when you are dealing with derived units and units that have exponents on them, you must also do the same exponential operation to the numbers associated with the conversion factor, meaning that you also must realize that 1 cubed meters cubed is equal to 10 cubed decimeters cubed. You must do that, or else your value will be incorrect for this particular problem. So if we looked at and use our calculator to compute 1 cubed, we would know that that's equal to 1. 10 cubed, we can do on our calculator, is equal to 1,000. And now we have our dimensional analysis set up and ready to go, remembering that it's multiplication on the top and division on the bottom. So we have 5.66 times 1,000 gives us 5,660 decimeter cubed. If we wanted to report this in proper scientific notation, that would be 5.660 times 10 to the positive 3 decimeters cubed. So here is an example of where we use dimensional analysis. The only difference in this one is because we're working with a derived unit that was cubed, we must also cube our conversions factors. All right, now let's look down a little bit further and let's look at 2. Expressing the results of the following computations to the correct number of significant figures. And let's do 2G. Let's write down the problem. We have 0.00300 times 16.254 times 7,000. And that's all divided by 2.311 times 10 to the negative 5. Okay, now we have our problem. We must also, there is a period here. I did not see that. 7,000 with that decimal. The best thing to do in problems such as this, where we have multiple operations, multiplication and division, is to go ahead and determine how many significant figures are your lowest amount and your least amount. Since we are working with multiplication and division, the answer must be reported with the least amount of significant figures based on the least precise measurement. And the least precise measurement in this particular case is going to be 0.00300. Why? That's because this value has only 3 significant figures. Which means that since we are only dealing in multiplication and division, we don't have to separate these. We can compute this all at the same time. So going to our calculator, 0.00300 times 16.254 times 7,000 divided by 2.311 times 10 to the negative 5 will end up giving us a computed value of 1476969.71. This is not going to be our correct answer because we have not rounded it to 3 significant figures. The third significant figure from the left will be 7, which means that we must use the number 6 for rounding purposes, which means that the properly reported value of this computation should be 148,000,000. We do not need the decimal or the zeros afterwards because that would give us more significant figures than we need. Our significance stops at 8. Here is your correct answer. All right. Let's look at one more problem that involves multiplication, division, and either addition or subtraction. So let's look at 2f. 2f gives us that 3.32 times 10 to the 5th power minus 4.5 times 10 to the 4th power, all divided by 83.12. All right, this problem is different from the previous problem because we have now multiplication and division in the same problem. So we must now separate our operations first and then determine significant figures for each operation separately. So that means that if we wanted to look at the numerator or the subtraction problem first, we see that we do not have the same exponents. And it is hard for us to multiply the same, it's hard for us to do the subtraction, when our exponents are not the same. So the best thing for us to do in this particular case would be to change those values so that they are the same exponent. So we can make this number 33.2 times 10 to the 4th power minus 4.5 times 10 to the 4th power. That will then allow us to do a direct subtraction and our exponent will not change. From our calculator, we see that that is equal to 28.7 times 10 to the 4th power. We've also noticed that we have 1 digit after the decimal, and in our final computed answer we have 1 digit after the decimal, so we do not have to do any rounding for that particular number. Now we must take 28.7 times 10 to the 4th power and divide that by 83.12. Remembering our rules for multiplication and division say that we must report the lowest number of significant figures for any value any value that's being used in the division problem. And in this particular case, we take 28.7 times 10 to the 4, and we divide that by 83.12. That value will be 345.2.839.269. And this is not the properly reported value because we must go back here and look at how many significant figures we have. Our numerator has 3 significant figures. Our denominator has 4 significant figures. Our answer, therefore, should have 3 because 3 is the least. That means we should be looking at the 5 because that is the third significant digit. And the number beside it is a 2. So the 5 does not round up. It should be 3450. We do not put decimal and we do not put the zeros again because that will make this number have more significance than is necessary. In this case, we can only show this to 3 significant figures. So here is your final computer answer for 2F. If you have any questions about anything on the worksheet, be sure to hit me up on Twitter or send me an email.